All right, welcome back. Today I'm going to solve really classic problem called two-sum. This is the first question that you see when you actually decide to do the lead code. This is the first problem that you see. The frequency of this question is really high, and a lot of companies actually ask these questions. Amazon, Google, Apple, Adobe, Microsoft, Bloomberg. So, all right, let's solve the problem. Before I explain this, if you like and subscribe this channel, that's gonna help me a lot to produce better videos like this. All right, let's think about the examples. Let's say nums. We take nums, array of an integer. We have 1, 2, 5, 3. And then for target, let's say that we have target of 4. So, all right, let's just try to solve with naive solution. So the first thing that I can think about is that iterate over this array one by one, and then just try all the combination of the two sum. So the combination is going to be something like this. 1, 2, 1, 5, 1, 3, 2, 5, 2, 3, and then 5, 3. We're going to try all of these combinations and calculate one by one. And this is 3, 6, and then 4. At this point, you can actually return two indices of 1 and of 3. So this is naive solution. So what is the time complexity of this algorithm? So time complexity, it takes big O of n squared, because we try every combinations of these numbers. So for example, it's kind of like you use nested for loop. So that's why it takes big O of n squared. And then what is the space complexity? We are not going to add any extra space complexity in this algorithm. So can we actually boost this algorithm? So let's actually think about what we can do with this, each numbers and then the target. So when you are iterating over this array, when you are pointing to 1, we want to find out if target is 4, and we want to find out if 3 is in the array. When we are pointing this 2 here, we want to find out if there's a 2 in our data structure. And when we're grabbing this 5, we want to find out if there is a 1 minus 1 in our array. And when we are pointing this 3, we want to find out if there's a 1 in our nums array. So how do we calculate these numbers? These numbers actually are calculated by target minus the number. So we can do target minus number. Then we can find out these values, the diffs. And then what kind of data structure is very good for looking up stuff? So I can think about hash map and then set. Both for lookup the key, it only takes constant time in hash map and set. But in this case, we are going to use hash map because we want to store the number and the index pair, because we have to return the indices in order to get the answer. So we're going to use the hash map. All right, now actually solve this with optimized solution. We're going to use hash map, and we're going to say m, and we're going to have this map. We're going to key value. We're going to store the number, the actual number, as a key, and then index as value. Okay. We are going to iterate the array again. We're pointing to 1, and then calculate the diff. The diff is target minus the actual number. So this diff is going to be 3. And then After calculating this diff, we're going to look up this map to see if actually 3 exists in this hash map. So if it doesn't, we're going to add this 1 and 0. All right. And then we're going to iterate over, we're going to point 2, and then the diff is 2. We're going to find, you're going to see if there's a 2 in this map, and there's no 2. So we're going to add this 2 and number and the index. And then we're going to pick up 5 and then see -1 is in the dictionary, is in our hash map, and -1 doesn't exist. We're going to add 5 to here, and then we're going to get to 3, and then we want to look up if 1 exists in our data structure. So when you do that, we already have key stored in the hash map here. So when you iterate it, when you get this point, you can return 0 and 3. And that is going to give you an answer. So time complexity of this algorithm is going to be big O of n, because we are only iterating this array one time while constructing this hash map. So the space complexity of this algorithm is going to be big O of n, because in worst case scenario, we have to construct this whole hash map here. So time, space. So in the interview, you have to communicate these pros and cons of using this extra data structure, because it is going to cost the space. If you're on the system where the space is really scarce, maybe you have to preserve the space, then maybe the computation time doesn't really matter, then you might go with a naive solution. But if time is more critical, then you can use this extra data structure in order to boost the time. Let's actually write code for this algorithm. I'm going to write naive solution, and I'm going to write this optimized solution. All right, now let's write some code. I'm going to solve with naive solution first. Naive solution. For naive solution, we are going to iterate this array with nested for loop. So for I in range of nums, and for j in range of I plus 1, and length of nums. And then while we are iterating over this array, we're going to check if nums I plus nums j is equal to target. So if we find the target, then return I and j. Let's try to run this program. All right, I got an error. Oh, this should be a length of arrays. Yeah. Let's submit. Okay, it passes faster than 85%. That's weird because it's naive solution. All right, okay, then I'm going to comment this out. I'm going to change the function name, and then let's actually code up the optimized solution here. So optimized solution, remember that we have map. So we're going to have num index pairs. That this is Python's hash map dictionary. And now at this point, we are just going to have for I in range length of the array. And what we're going to do is calculate the diff. Diff is equal to target minus nums I. So at this point, we're going to check if this diff is in the num index pair. If diff in num index pairs, then we actually found the answer. If there is a diff in the our hash map, return I and num index pairs of diff. After this, we're going to add the number that we just seen in this for loop. So we're going to do this num index pairs nums I is I. All right, return none for default. I mean, this is kind of meaningless because the prompt already says there's always an answer. But anyway, let's run this program. We got it. All right, so this is the end of the video. So if you think it was helpful, so please like and subscribe this channel. If you have questions or requests, or if you just have anything to say, leave them on the comment. So your support is really going to help me to create more videos like this. All right, thank you so much.